My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 272. In this lecture, we will try to understand failure cases of K nearest neighborhood algorithm, because this is very important to understand when the techniques do not work, where they fail. Here in this context, we have two cases. Let me say this is case 1, this is case 2. We will try to understand these two cases separately. First, let me consider case 1. In case 1, let's assume my query point is, my query point is here somewhere. Let me say this is my XQ. Let me assume this is my query point. If this is my query point, let me assume K equal to 3. Of course, K can be 5, K can be 7. For simplicity, I am assuming K equal to 3. We will see how things change as K increases. We will see all of that in future classes. Now, if my query point is here, if it is my query point, since all the three nearest neighbors, what are the nearest neighbors to this point? This is one nearest neighbor. This is another nearest neighbor. This is nearest neighbor 1. This is nearest neighbor 2. This is nearest neighbor 3. We have three nearest neighbors. All these nearest neighbors are blue points, or I can say they are positive points. We will end up declaring this query point as blue point or positive point, as it is surrounded by three blue points as K equal to 3. Just consider here, if my query point is somewhere here. Let me assume this is my query point. If this is my query point, these three nearest neighbors to this query point are red in color, or I can say they are negative class. Therefore, what will you conclude? What is your conclusion? I will declare this query point XQ as a red point, or I can declare it as a negative point. If my query point is here, somewhere here, if this is my query point, what are the nearest neighbors to this particular point? I have three blue points. I can say these three nearest neighbors as K equal 3, blue, or I can say are positive point. Therefore, I can declare XQ as blue point, or I can say positive point. In similar manner, if my query point is here, what happens? What are the nearest neighbors to these three nearest neighbors are red in color? Therefore, I can declare this point as I will declare it as my query point XQ. As it has got three nearest neighbors are red in color or negative class label. Therefore, I can declare this XQ as red, or I can say it is negative class. Observe these four cases. Now let me say, what if my query point is here? Let me say this is my query point, very far away from the rest of the points. So let me say this is very far. I can say what type of query point it is. Let me write otherwise. This query point is far away. It is far away from the points. Far away from the points in data set data set capital D. What is this data set? This is capital D. This your query point is so far away from the rest of the points. This is my given data set capital D. Now if I take 3 nearest neighbors, let me consider this is my first nearest neighbor. Let me say this is my first nearest neighbor. Let me say this is my second nearest neighbor. Let me say this is my third nearest neighbors. If you observe carefully, what happens? What is my query point? This XQ, what is the case? This is the case where query point is far away from the points in our data set. Now, what is the class? What is the class for XQ? What are the class? What is the class this one? I can say query point class is blue or positive class. Why? Because KNN for k equal 3, you have got majority points are blue points. Therefore, I can declare it as blue point. I can declare it as positive point. But does it really make sense? This is so far away from the rest of the points. Does it really make sense to declare it as a positive point or blue point? It seems little absurd. It seems little absurd. It seems little untrue. It is not true, isn't it? Because I don't have any points which are really close to this particular query point, isn't it? All these points are very, very far away from my query point XQ. So when you have a query point very, very far away from the rest of the points in the data set, you are not very sure. You are not very sure. You are not very sure. You are not very sure of its. You are not very sure of its class label. It's a class label, as it is very, very far away from the rest of the points. Similarly, I imagine if I have a point here. Let me say like this. Imagine if I have some point here, isn't it? Imagine if I point here. Imagine my query point is here. First, what is my first neighborhood here? My first neighborhood, let me say this is my first nearest neighborhood. Let me assume this is my second nearest. I am assuming this is my third nearest neighbor, isn't it? This is my let me assume this is my first nearest neighbor. This is my second nearest neighbor. This is my third nearest neighbor. What is the color of first nearest neighbor? Blue color. Second nearest neighbor red color. Third nearest neighbor red color. By majority voting, you have got 2 red labels. This is just an assumption. In that case, I must declare XQ as majority voting is red. I must declare XQ as a red or negative label or negative class, isn't it? No, because all of these 3 points are so far. Just see, these are so far away from the rest of the points. So even in cases like this, if the data is well organized, just say you are declared, but does it really make sense? Again, it is an absurd case. Again, it is an absurd case, because what is the reason? In such cases, better for algorithm to say I don't know, isn't it? Still same case, isn't it? You are declaring it as a red class or negative class, but actually it is far away from the entire data set, but it is not true, isn't it? So KNN, even in cases like this, if the data is well organized, because the whole data is mostly, just say, is it not well organized data? Just see, let me show like this. Most of the data is blue here. Most of the data is red here. Most of the data is again blue here. Most of the data is red here. This data is well organized, even here. But what happens in those cases, so in cases in which KNN may not work as well as you expected, it's a very easy to understand it geometrically. This is one case. This is a case where data is well organized, but still KNN may not work. KNN is not working as we are expecting. This is case 1. Now we will try to understand there is another case, that is, let me say this is case 2. What does it mean? Just observe this one carefully. It's basically, what is this data? It is basically jumble of positive points, and negative points, isn't it? Jumble of positive points and negative points. Basically, they are random. To put more, this is random data. They all are random. To put it more mathematically, they are basically randomly spread. They are basically randomly spread data. Randomly spread, is it not? This is my 2D space. This is my x-axis. This is my y-axis. It is in 2D space. This data is randomly spread data. If my positive points and negative points are randomly spread, so what happens? So take a query point here. Let me assume this is my query point xq. How to determine? This is one neighbor, this is another neighbor, this is first nearest neighbor, this is second nearest neighbor, this is third nearest neighbor. What does it mean? How many blue points are there? There are 2 blue points, or I can say there are 2 positive points, isn't it? 2 positive points, 2 blue points, 2 blue points or 2 positive points, 1 red point, or I can say 1 negative point. Most like this, what is my query point? I must, as according to majority voting, I must declare xq as blue point or positive class. It is most likely to be wrong. It is most likely to be wrong. Most likely to be wrong. If your data is randomly spread, if your classes are tightly jumbled up and intermixed, it's completely mixed up data. It is completely mixed up data. It is completely mixed up data. There is no information. In this case, there is no information, isn't it? If I take some point here, I must take nearest neighbor. It says positive point. If I take something like this, there are 2 red and 1 blue point, this is query point, it is declared as red point or negative point, isn't it? There is no useful information at all. There is no useful information at all. In case 1, we have useful information. Just go back and check. In the case 1, you have useful information where positive and negative points are grouped. Just see in case 1, just see. Positive points and negative points are grouped. We have information, isn't it? Whereas in the case 2, we don't have useful information. Most machine learning algorithms, in this case, most machine learning algorithms fails in this particular case, that is case 2, because there is no information that you can leverage. It's simply noise data. It is simply, I can say, noise data. So we have to be careful when you look at the data. These are 2 cases, many cases in which KNN fails. I will discuss all those cases in my future classes. These are the simplest cases where KNN miserably fails, and because you are using its geometry to understand, we are actually trying to take advantage of geometry. In my future classes, I will discuss few more cases where this KNN fails, why this KNN is called as lazy learning algorithm. There is a name like lazy learning. What is this lazy learning? All those things I will discuss again. This KNN is, if you speak strictly, it is computationally expensive algorithm. It is computationally expensive algorithm, given that it stores all training data. It has to store all training. It has to store all training data. It is computationally expensive, required high memory. It needs required high memory. This is another case, another disadvantages with KNN, as it has to store all training data. When large data, prediction stage might be slow. If you have large data, this prediction stage might be slow. Prediction stage might be slow. Accuracy depends. Accuracy of KNN depends on the quality of the data. Yes, this accuracy depends on quality of this data. Is the data where you cannot have quality. All these things I will discuss in my future classes. Just time being, go through this lecture. If you have any difficulty, just keep a comment. Thank you very much.